Hello. Okay, so today we're going to do our first lab video. Let's see how this goes. I'm interested to see what kind of mess I can make of this, right? All right, so what do we do when we go to the lab? Well, before we go to the lab, or the first thing we do once we're in the lab, we should have done this really before, is, we're going to say, let's look at what we're going to do, and we're going to know what we're going to do. So we're going to find in the manual the experiment we're doing today. That is non-ideal gas behavior. So I'm going to go to my laboratory notebook, right? My good old Westchester University laboratory notebook. And I write non-ideal gas behavior as the title on, I'm starting on page 26, it just happens to be on this one. And I'll put a date, right? Title and date to start things. And now I need to figure out what I'm going to do today. I should have done this before I got to lab, right? I read through this and I go, we're going to be measuring the compression factor. How do we do that? We need to know the pressure, equilibrium pressure of a gas in a known volume. We need to know the temperature and the mass. All right, so what do we need for that? We'll need an isothermal system. We're going to have to set that up. And we're going to need some cylinders of gas. Okay, good. And we're going to need a cylinder, known volume with some valves on it here, right? And a pressure gauge. Okay, so we need all of that. We're going to have to figure out how to hook that puppy up, right? Okay, so we read through the procedure before we get to the lab. We find all of the stuff we need once we get to the lab, right? What else do we need? Plastic bath jar, right? And we're going to fill that up with water, and we're going to equilibrate that to a particular temperature. So that's the bath controller there. So the first thing it says is wear your eye protection. Right? Yeah, right, we're in lab, so we're going to wear some goggles here. And then it says prepare a water bath at 300 Kelvin. Very often we need to do things isothermally, right? And it takes a while for things to get to temperature. Get the bath to temperature first. So the first thing we do is we find our controller, right? We get it into our bath, we hang it up here on the back, boom, secure it with a little knob that we tighten there. You'll notice some metal coils down there and that black plastic tubing stuff. That's where you're going to be circulating water through there. The water level has to get over those valves, or else you're going to hear an alarm when this thing gets turned on. We turn it on. Right? There we go. We turn that puppy on. There's an on-off switch there. We'll notice some other things. You might not be able to see the digits that are up here. That's where the temperature is indicated up there. Down here, right, there's a digital temperature reading. That is the actual temperature reading, and that is the readout where the digital display is where you set up the temperature that you want to regulate. Down here is an analog device. Remember, analog is just a knob. You can pick any value kind of thing, and it goes from 0 to 120. This is not where you set the temperature. This is a safety feature. The temperature you set down here on this analog knob, that is, you can't heat above that temperature, right? And if you try to set the temperature above this value, an alarm will go off. Again, we don't want the alarm to go off. So we set this to like 60 degrees. We're not going to get anywhere near there. We're going to go to 300 Kelvin. 300 minus 273.1. We need to go to like 26.5. So we got up and down arrows, and we got a dot. Don't press the dot. But you like to press the dot, you go, oh no, what's the dot? The dot actually lets you do things like you can change, can you hear that? Can you hear that? You can see some bubbles coming out. You can change the power on the pump, all right? Things like that. We don't have to get into there. There are other things. What we want to do is we're just going to use the up and down arrows. That's how we can set the temperature. If you hold on to that, it'll start blinking degrees C, and then you're able to hit down. This is how you set the temperature you're going to regulate to. So I'm going to set this to 26.8. And it's one of the first things I do because if you have all this water in here, then it's going to take a while for it to regulate to temperature, right? Okay. Now, next thing I have to do is I have to fill, I already have this filled to a good extent, but I need to fill it to the right extent. What's the right extent? Well, I'm trying to keep this thing at a constant temperature. So if the water level is only up to here, then I'm only regulating the temperature down here. I'm not regulating the temperature up here. I need to hang this on the side, and the water level has got to go all the way up to the top. I don't have enough water. I need to fill some more water. So I'm going to do that. we can use a hose. Oh yes, we've got these things here. You don't want to be pouring it. Maybe if you're just pouring a little bit, you could use it, right? But we're going to use hose. We're going to use a hose. Remember that the flow rate is proportional to the cross-sectional area of a tube. So if you have a huge amount that you need to fill, use a big tube, right? Cross-sectional area. Flow rate is proportional to cross-sectional area. That is the square of the diameter. So if you use a little piece of Tygon tubing like this, okay, if you only want to put a little bit of water in, that's fine. But if you want to fill this whole thing, this will take forever, folks. Maybe you don't want to get out of here today, but if you want to fill up a whole lot of water, pop this puppy on there, secure it, fill it up. We need it to be right near the top because we need to fill, we need to completely cover, right? If I look at the amounts here, we're going to end up hanging this inside, and the water level, we're not quite there yet, right? The water level should completely cover the cylinder so that we can keep it at temperature, right? Only the stuff that's submerged will be, oh yeah, that's looking pretty good. We probably could go a little bit higher. But don't forget, when we stick it in there, it's going to displace low. So we might top it up with the beaker or something right at the end. Now, we need to, under supervision, figure out how to put gas into the cylinder, right? And we're going to put some helium in there, and then we're going to purge the system, right? What we're trying to do is we need to know the mass of this. Oh yeah, that's right. One of the things we're going to do is we're going to measure the mass of the cylinder filled with helium. All right, so I can put a little note in my notebook here, mass of cylinder with helium, right? Because we're told what the mass of the helium is going to be in here, but we need pure helium in here to figure that out. How do we do that? We're going to fill this, right? We don't know what's in here now, so we're going to fill it with helium, overpressure it, release, it'll come back down to atmospheric pressure, fill it again, do that several times. You're going to purge it 3 times, that way we'll get pure helium in here. All right, we got a gauge here, we can turn that on. Turn that on, and if you can see the numbers, right now, open up the valves, they're open to atmosphere, and what does it read? 0. This gauge measures PSI, or megapascals, gauge pressure. 0 is 1 atmosphere. There's absolute pressure and there's gauge pressure. Sometimes gauges measure the pressure above atmosphere, sometimes they measure the total pressure. This one measures the pressure above atmosphere, right? Okay, so now what we want to do is fill this up with helium. Let's take a look at how we're going to do that. Okay, we do that in the following manner, all right? We'll come over here, we'll see our cylinders, right? We've got CO2, argon, and helium. Here's the helium, all right? And tanks like this, big actually not stainless steel, just carbon steel. They have a main valve up here. We open this one up, boom, and that will show us the pressure on this gauge here, the pressure that's in the tank. This is the regulator valve. The regulator valve regulates what pressure will come out. It's cranked all the way up now, and it's set to about 140 or so kilopascals, all right? Then there's a valve here, and that's going to let gas out, right? So if you open this valve, it's not attached to anything. You hear that? Yeah. Yeah, if you have a big leak, you'll hear it. Oh, wait a sec, we don't have this attached to anything yet. All right, so we've got that open. It's going to let out some gas. Now we need to hook up that to our cylinder, right? Okay, so here's our cylinder, and our cylinder has these swage lock fittings. That's what these guys are, right? And the helium tank, boom, it's got swage lock fittings too. All right, these are stainless steel swage lock. They're good for vacuum. They're good for high pressure as well. And there are a couple of components that we want to note. There's the metal tube right there, and then you'll notice these sort of angled things, right? Those angled things. There are actually 2 of them. Might be hard to see that there are 2 of them there. They're called ferrules. There's an inner ferrule and an outer ferrule there. Get nice and close. Ooh, now you can see that there are 2 of those. That's those two things. And then there's the nut turns, right? So the way that you get a good high pressure seal is first set the tube, set the ferrules into, right, the other connector over here, then put the nut on and tighten it just finger tight. Okay, so that's good. Then we need to use some wrenches. 2 wrenches, these are 1/4 inch swage lock fittings, so there's a 1/2 inch wrench that we need to use, 1/2 inch, and a 9/16. The 1/2 inch wrench just goes on the body here. We're just gonna use that for stability, right? The 9/16 goes on the nut, right? And we just need our 1/4 turn. That's all it takes. You don't have to go all gorilla crazy on a 1/4 turn, and it will be sealed. How do we know if it's sealed? Oh, wait a second. We've got a valve over here. If we open that up, listen. If it weren't sealed, I'd hear, right? Oh, okay, so it must be all right. And now we've got these 2 valves closed, and it says 0 pressure. 0 pressure. Now I'm going to open this up, turn that on, open it up, and it's going to fill to about 1.3 megapascal. Yeah, 1.3 or 0.13 megapascal. Close this valve, which this valve is going to close off the cylinder, and now close off the tank. All right. If I open this valve, it would vent out everything here. What I'm trying to do is vent this part, so I need to open this valve. And now if I open this one, I vent out everything on that side. I vent out this side too, right? Close. Fill again. Close. Because I don't want to empty the tank. I want to empty our cylinder here, right? Not our source. So I do this 2 times. And a 3rd time. Close both off. Now I know I have 1 atmosphere of helium, and since I purged it that way to above pressure, I've cleaned out whatever gas was in there, and I have just pure helium. I've let off the overpressure on here, right? So I can disconnect the swage lock fitting, right? 1/2 inch on the body, 9/16 on the nut. Boom, open it up, loosen the nut. You might have to wiggle it a little bit on some of these to get it off. That's fine. All right, I'm done with the helium. Whenever you're done with a high pressure tank of gas, don't leave it open. If you're done with it, make sure this is closed and close the main valve, right? Because if anything happens, we don't want the helium going all over the place. We want to make sure that we're operating safely. So whenever you're done with a high pressure tank of gas, make sure you close the main valve. All right? Now, what do we got next here? We know what we have in here. It's pure helium at 1 atmosphere of pressure, okay? 101 kilopascals, right? And we need to know the mass of the cylinder with helium in it. How do we measure the mass? Okay, we measure the mass with a balance. We've all measured a balance, but we've got to make sure that we have just the cylinder clean and dry, right? We haven't put it in the water yet, so we don't have to worry about drying it off. But later you will have to worry about drying it off, because if it's not dry, the mass will be too high. And then we're going to stick it on the balance here. Oh, wait a second. Always make sure, take a look at the balance. Is it on? Yes. Does it read 0? Make sure it wasn't teared by somebody before, right? Make sure it reads 0. Now we're going to pop this on here, right? We stick it on there, and we are improperly measuring the mass. Why are we improperly measuring the mass? Because it's not just on the plate. It's touching down. We can't let it touch down, right? If it touches down somewhere, then you're going to measure too small of a mass, right? You have to make sure that it's on the plate. All right, so we do that. We measure that. Oh, wait a second. I need this number, right? Where does the number go? Do I just try to remember it? No! I don't just try to remember it. This is why you have the lab notebook, right? So we've got a lab notebook, and you're going to write down that the mass of the cylinder with helium is 1721.79 grams. 1721.79 grams. I need that value because I know that this contains 0.05 grams of helium, because it says that in the laboratory notebook. So if I subtract the two, I'll get the mass of just the cylinder. The mass of the cylinder with the helium, 1721.79 grams, and I note that in my laboratory notebook. So we're done with the helium, but we've got a tank of CO2 here. So again, we're going to attach the swage lock fitting, seat the ferrules, finger tight with the swage lock fitting. The 1/2" wrench goes on the body. The 9/16 wrench goes on the nut. So we turn, we've got it sealed up. Turn the gauge on again, and now we want to fill it with CO2, right? What are we going to do? We're going to purge it again. Don't fill it to like 1,000 megapascal. No. You know, a couple hundred kPa. 0.2, 0.3 megapascal. That's fine for purging, right? So we open up the valve on top of the CO2. The regulator is already turned all the way up. We don't have to change any of those, right? But we're going to have to let the CO2 in. First of all, these are both closed. Open this up. I don't hear anything hissing. Sounds like we've got a good connection, right? So now I can open this up. And I can put in, close that. If I open this guy up, I can let in just a bit of gas. I can vent off the gas. All right, you'll notice that if I really open it up, it goes up. All right, so you might want to open it up slowly, and you're going to vent off the gas that is inside the cylinder, get it back to atmospheric pressure. All right. This CO2, it's not toxic, but it is an asphyxiant. So I don't want to be sitting there going, oh, I wonder what CO2 smells like. No, we don't want to knock yourself out. Okay, if we have these two both open, right, then I'm going to vent to atmosphere. Don't want to do that. Close this one, leave that one open. Vent this puppy up to, 0.2, 0.3, and then release slowly the CO2. Get it back to atmosphere. Close it back off. All right. If you get this thing up to 6 megapascal, 7 megapascal, and open this up, you may see a plume of gas come out of here with condensation. When you rapidly expand a gas, it will generally cool, and you can get like a real plume of stuff. Be careful about that because it can get to cryogenic temperatures and can give you a burn. So we open things up. We slowly let off the gas, keep our head away from there, we keep our hand away from there, right? Let out the gas that we've got here. We don't take it to a megapascal, we take it to 0.2, 0.3, right? That's it. Good. Then we finally load it up, fill this up with a fair amount, and it tells you how much, right? In the manual it says you're going to fill it with CO2, and do not exceed 6.9 megapascal, right? 6,900 kilopascal, 6.9 megapascal. So we've filled this puppy up, close things off. To disconnect it, once I'm done with the CO2, right, I close that. You always close the main valve afterward. But if I'm going to disconnect this, I want to close this off, make sure I've got the pressure in here, vent off the gas that's in this, because when I open this, I want to let the gas out in a controlled fashion. Put our wrenches back on there, open things up. Good, we've got our cylinder, take it off. Very good. Then we're going to hang it inside our tank. We're going to make sure that the water level covers all the way up to the top. Oh, wait, I need just a little bit more to cover the top of the tank. Then, but I make sure I cover the tank, right? I don't want to cover the valves, right? Don't want to cover the gauge, I'm just going to cover the tank. So I've got it filled up. Oh, and it's at temperature because I put it at temperature long ago. Now what I need to measure, right, is, what does it tell me? For each one of these at 300 Kelvin, we want to measure the equilibrium pressure and the mass of the cylinder, right? Okay, when do I measure the mass? Mass is independent of temperature. I could have measured the mass before I put it in here, right? Could have measured it, that would have been nice because it was dry at that point, right? Or I can measure it after it's equilibrated. It doesn't matter for the mass. But for the pressure has to be measured while it's at temperature and equilibrated. When is it equilibrated? When the pressure stops changing. Now, the first time you do this, you've got a whole bunch of gas and stainless steel and all that. It's going to take a while. Give it 10 minutes. Just read the pressure you got now. Whatever. You know it's going to take a while. You got 10 minutes. What are we going to do in that 10 minutes? Oh, we could look at what we've got to do. Oh, wait, one of the things we're going to have to do is we're going to need a bunch of values of pressure in megapascal is what it's on there, and the mass in grams. So why don't I make a table in my book right now, my lab notebook, because I know it's going to take some time. I know what time it is. Yeah, I'm going to wait 10 minutes, right? And then I'm going to measure the pressure. Is that the equilibrium pressure? I don't know. What I'm going to do in 10 minutes time is I'll measure the pressure. Okay, there's the pressure value. And then, right, I'm going to give it another couple of minutes. And then I'll measure the pressure again. If it's changing, it's not equilibrated. So I'll come back in a couple more minutes and measure the pressure again. Oh, it's not changing anymore. When, after, say, 10 or 15 minutes, the pressure is not changing anymore, then you know it's equilibrated. So I'll write down the pressure, the equilibrium pressure, which I measure while it's in the tank, right, in the water bath, when it's at the equilibrium pressure that I've set up here, right, the one I know, 300 Kelvin. Then I'm going to measure the mass. And when I measure the mass, it has to be clean and dry. Right, so I'm going to take it out of here. And I got to make sure that it's dry, right? So to make sure it's dry, we've got to wipe it all down, make sure it's dry, and then we measure the mass. I note this in my notebook. Take down the mass. Then I need to change the pressure. It says take it down by 600 kilopascals, or 700 kilopascals, about, right, roughly. So I'm going to let some gas out. Okay. Do I measure the pressure now? No, I don't measure the pressure now because it's been out. The temperature is changing. Plus, remember, when you release gas, it tends to cool, right? So there might have been some cooling that went on here as well. Okay, so we don't know the temperature anymore, plus I'm warming it with my hands and all that kind of stuff. The pressure doesn't matter, it's not the equilibrium. But I do know that this is the amount of gas, so I can measure the mass again. Oh, there we go, I've got the mass. I'm going to put that in my book. Then I pop this back in, allow it to equilibrate, and measure the equilibrium pressure. Okay? I do that for CO2. I do that for argon in the number of steps that it says here. I get the pressure and mass data for CO2 for argon. All right. And then we're going to go to the data analysis. data analysis, I can shut this off now, right? Data analysis says make two separate tables. We're going to make the tables. Remember, tables have a caption. They're numbered. The caption goes above. Each column of the table has a header. The header says what the variable is, like pressure, P, and its units. It tells you in here that it wants pressure in kilopascals. It tells you that it wants mass in grams. Include the units in your table, right? And you can calculate the quantity in moles and the molar volume, the inverse molar volume, and the compression ratio. And you're going to make one table for argon, one table for CO2. Great. Then you're going to make a plot. We're going to make a plot. That plot is going to be compression ratio Z. What are the units of Z? Well, when we read before we came to lab, and then we can go over it again, we'll see that there aren't any units of Z. And molar volume, oh no, it's inverse molar volume, 1 over molar volume. Molar volume, right, molar volume has units of cubic meters per mole. But that's not what we're plotting. We're plotting 1 over molar volume. There we are. Make sure you put the units in there as well, right? Then we're going to plot up our data. Hey, we're going to get a nice straight line. We're going to fit that line in Igor, right? And the slope is equal to B, the second virial coefficient, and that slope is going to have some uncertainty in it, delta B, right? And that's determined by, oh, wait a second, we did this in the first Igor experiment, something exactly like this, and you can use that. Don't forget, slopes, right? Slopes for dy dx, they have units. The dimensions of slope are set by, this is backwards, so it's really crazy, right? Are set by the units of the axes, the y-axis divided by the x-axis, right? So the slope itself has units of cubic meters per mole. B is the value of the slope. The uncertainty is the uncertainty in the slope is the uncertainty in B. Straightforward, this one, good one to start off on, right? Okay, so you're going to have plots like that, one for each gas, and then put the two together to make a comparison. It says compare the results for B to the accepted values. You're going to find the accepted values either in the textbook or in the CRC handbook, right? And compare values of B. I don't want you to compare values of Z, right? No, don't compare values to Z. Z is changing. B is a constant for a gas, all right? At a certain temperature, it's constant. And that's what you're going to compare. The second virial coefficient, B, is equal to 0 for an ideal gas. The closer you are to 0, the more ideal the behavior. Compare CO2 and argon to each other to see which acts more ideally based on their values of B, right? And we can make both a determination of what's the magnitude of the two, right? And which one is more ideal or less ideal. And is it significant? If they differ outside of the uncertainty, then you can really say it's a significant result as well. All right, so that's what we're going to do. Oh, wait, there's one more thing. No experiment is complete until the experiment is cleaned up. All right, so we've got all the data in our lab notebook. Very good. I'm going to set that to the side. We know what we're going to do with the data. What do we do at the end of an experiment? At the end of an experiment, you put everything away. Okay, so it goes back, everything goes back in its proper place. You make sure that the tanks are closed. The tanks are closed. Great. Then, oh, wait a second. We've got the temperature controller and the water bath. Okay, so we've got to get that out of here. It's going to leak all over the place, right? We try to avoid floods. If you're going to move things around, unplug them, right? We try to avoid floods. Floods, you know, you will have cleaner working space if you have periodic floods, but we'd like that to be an orderly process, not a disorderly process. So we take this and we put it back to where it should go, right? Should go up on the place up there. And then one of the most useful things you'll learn, everybody enjoys this one. How do I get rid of the water that's in here, right? Okay, we can do siphoning, right? Again, flow rate is proportional to the cross-sectional area of your tube. You use a tube like this, it's going to take till next Thursday, well, maybe next Tuesday, who knows, right? So use the big tube. Now, you need to get complete filling of this. You don't, no, not enough, right? So we've attached it to the water here. You flow the water until water is coming out. When you submerge, you turn that off, and boom! You've got flow now. And you will get rid of the liquid very rapidly out of here without creating a flood. All right? That's the way you do proper siphoning, right? You flow the water through, and then you disconnect it and let it all flow out of here. So that's our non-ideal gas behavior lab. We can even get the last little bit out of here by turning it to the side, and it'll give you a nice big burp at the end because it's just so happy to have done a job and done a job well. All right, here we go. Ah, that was satisfying, wasn't it? Everybody enjoys doing a job well done. Here we go. The water. We're done with that. We can stick that puppy away. Clean up all and any water that we got in a non-sink type location. Set that up here to dry. And we're good to go.